a interview question. I came about it on Pramp, but I suppose it's probably some other places too. But it's pancake sorting. It's just essentially it's a sorting an array. That's just another sorting algorithm. That's kind of like with your pancakes. If this is a stack of pancakes, and you want to get the smallest pancake on the top and the biggest on the bottom. And what it's like, say this is an unordered array here with your pancakes. So if you wanted to flip this point right here, what would happen is this pancake would be on top, this one still be in the middle between these three, and this one would be at this position. But can we do a series of flips with your spatula, so you can get the biggest pancake on the bottom and the littlest on top, and then just in order. So so just to explain that, you just need yeah, let's just go over a high level here. So here's your unordered array, and a flipping would be, let's just say you want to flip this array. What you would do is you'd flip it, and you want to flip it to the third element or the second indice. So 11 would go there, and 9 would stay in the middle, and 43 would be there. And that's like your only tool. So in order to do that, and what we want to do is get this so it's 1, 2, 4, and all the way to 81. So the way to do that is, thinking about it, here, let's switch this to red, is you want to get 81 to here, right? So that's your whole goal. And then once you're from there, then you can kind of recursively almost then work on the whole rest of the array like that. And once you're from there, at this point of this array, then you want to get, what's the next biggest number? 65. So then you want 65 to be there. Then you want 40, and then once you're done, you cement that, and then you work on this subarray, and you want 43, and you kind of lock it in there, if that makes sense. So that's how I like to think it. So essentially, you're just flipping, and you're smartly flipping the biggest element to the end of the array, and then decorating the size of the array that you're working on. Index. So the rightmost index to search is a variable I like to use, and that's preset to the length of the array. So it'll be 1, 2, 3, 4, 5, 6, 7, 8. So it'll be 8. Well, this would be just 8. And then while, so then like I use the word while, so you want to use a while loop. Once you do your flipping logic and you get 81, the maximum element in the last spot, then you want to decrement this to 7, and then you'll be working to find this spot. Then you find it, you decrement it to 6, so on and so forth. So you keep doing that until you get while the current index search is to 1, or 0, I mean. Because that means once you get to 0, it's like everything, you can't flip no more, and then the whole thing by then should be sorted. So with code, you have to write some helper functions, and just for the sake of arguing that it's an interview and you have to build things from scratch, we'll have a flip function and then a find max function. Actually, I want to change this name here. Find max element index. There, because yeah, it'd be a little bit more explicit. So, anyways, so the flip function, all you want to do is just flip spots in the array. So you have your array, you want to flip up to the 0 spot all the way to the I. So you start at the 0 spot, and while I, or the start, is greater than the place, the index you're searching for, you want to create a temp. And essentially, you're deleting, mutating the array, and you get a copy. And then from here, you set the copy. You set left element to copy, or to the furthest right element. Now, so essentially you have like if you're flipping like one, two, three, four. If you're flipping 1 through 3, after this step, it's going to be, oops, it's going to be 3, 2, 3, 4. So you mutated and deleted the 1, but since we have that copy of the 1, then we'll set that 1 to here, right? And then you decrement or you increment the start, so then you want to move to the second spot, and then I move inward, leftward, and rightward. So that's the flip. That's the one way to do the flip function. There's other ways too I saw. So and then the second helper function, what you need is you want to find the max element in an array up to an nth point. So I'm going to build this from scratch as well. Because the simple way you can do is just return the minimum or maximum in this point of array in this subarray up to a suffix. So, but essentially, what this is in Scratch code is you just use a for loop, and you have a holder variable, say the max element index, and while you for loop through the indexes of the array, if the current one is bigger than the one you're currently looking at is bigger than the one that's already set, then set the max element index to the index, because I in this case is an index. And you just return index when you're done for looping. So, so it's maybe two little sub problems that you have to kind of make up to in order to make Pancake Sort. But now getting to the meat and potatoes of Pancake Sort, like getting what I said earlier. So we want to start with the rightmost index to search. So that means at the beginning we want to search the whole. We want to search this whole array, right? So whatever that length is, and just get the length of the array right there, length of the array. And while that's greater than 1, so pretty much saying it'll terminate once we get here. So because that's the first one. The first step, yeah. So we look at this whole thing and say, what's the biggest element? Then we find it, and it's 81. So it's 0, 1, 2, 3. So this would be 3. So if the max element 3 is not equal to the rightmost minus 1, this minus 1 just means the end of it. So if, just in case, this is checking if 81 isn't in the last place already. That means if it is, we don't have to do anything, and we can just move on to the next and shrink it and move on to this part of the array. But if not, which is an unlikely case, what we want to do is ignore these prints here, is flip it so we get the move the end. Yeah, I'm just reading. Move the max element to the beginning of the array. So what we first want to do is move 81 to the beginning, and then once we're done that, then we can flip the whole array and get 81 to here. So we're going to do 2 flips. So first flip, get 80 or the maximum element to the front, and then move it to the end wherever we're iterating over. Which the first case, the face space is the whole array, but the second space would be the everything but the last array, and like so on and so forth, and we'll do it there. So we do that. Yep, so that's the first one, and then that second one that I said, now we want to move it once we get 81 to here. Now we want to move it to here, and this is what this flip does. And that's it. So, and then once you're done with that part of the algorithm, then like I said, now you want to work on this subspace, and you rinse and repeat until you get all the way to this element. So, and yeah, just to show it, I had some print functions just to show what the flipping does. So we have this array here, which is the one I have here as well. If we run this, hopefully, yep. So the first one, like we said, this is our original array. It gets 81 to the front, and then now we're going to do another flip, and we get 81 to the back. So that's what we do. We get 81 to the back. While we're doing that, we're flipping the whole thing. So you can see like one's going on the journey from the back to the front, stuff like that. So then once we locked in 81, now we want to find what's the next biggest element in it, which is 65. So we don't have to do anything after post flip because it's already at the beginning. But now we want to get 65 to the end of the second spot of the array, right? Since right mouse index got recommended by 1, that's why it's here. So now right mouse index search is decremented by 3, so we're looking to cement this one in. So what's the biggest element in this array? It's 43, right? So how we get 43 flipped to the front, and then post it, we get it to the spot we wanted, and so on and so forth until you're all the way at the bottom here. And that's how Pancake Sort works. I forget what the runtime was. It's pretty gnarly. It's pretty not efficient, but it's just kind of a fun way to test your ability to iterate and manipulate arrays and stuff. So what was it again? What would this be? Looking at our code. I think it's n squared. The worst runtime. You always have to be flipping constant work, and I'm pretty sure, yeah, it's n squared. Because you have to do a flip here, flip there, flip there, flip, 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 flip. Yeah, so